Hello, everyone. Good day. Today's topic is from the machine learning techniques candidate elimination algorithm. So, what is candidate elimination algorithm? So, the candidate elimination algorithm incrementally builds the version space given a hypothesis space H and a set of E of examples. So, the examples are added one by one. Then, what happens is that each example possibly shrinks to the version space by removing the hypotheses that are inconsistent with the example. So the candidate elimination algorithm does this by updating the general and specific boundary for each new examples. And you can consider this as an extended form of the findest algorithm and consider both positive and negative examples. So that's what we do in the finders algorithm. We normally take only the positive thing in the finders algorithm. Since this is an extension of candidate elimination algorithm, here we are taking both positive and negative examples. Actually, positive examples are used to here as the finders algorithm. Basically, they are generalizing from the specifications. So while the negative example is specified in the generalizing form, and terms used are like concept learning, general hypothesis, and G, that is specific hypothesis referred by S, and person space. So what is concept learning? Concept learning is basically the learning task of the machine learned by trained data. So the machine learns by training the data. A general hypothesis is not specific features to learn the machine, and it is referred by G is equal to the question mark and so on. It's a number of attributes. What is question mark is anything. It can take any values. And specific hypothesis are specific features to learn machines. Specific feature. So that is a specific hypothesis, and it is represented by S is equal to specific hypothesis S is equal to pi. The number of pi depends on the number of attributes it has. And what is version space? It is an intermediate of general hypothesis and specific hypothesis. It not only just writes one hypothesis, but a set of all possible hypotheses based on training data set. Algorithms step 1 load data set. Step 2 initialize a general hypothesis and specific hypothesis. Step 3 for each training example. Step 4 if example is positive example, if attribute value hypothesis value, do nothing else, replace attribute value with basically generalizing it. Step 5 if example is negative example, make generalized hypothesis more specific. Example, consider the data set given below. So this is the data set, and you can see the sky temperature, humid, wind, water, forest, output, and if it's so if it's sunny, these are the things: warm, normal, strong, warm, same, or S, and the output is S. And sunny means warm, high, humidity is high, and the wind is strong, and water is warm, and forest is same, and output will be yes. Rainy, you will get output as no, it is negative, and sunny means again output is yes. So algorithmic steps, what are they like? Initially G, which is G is nothing but we have discussed here general hypothesis, and it is referred by question mark, and it means it can take any values. Yes is pi or null for this particular thing. For instance, one sunny, comma warm, normal, something like that, and positive output. G one is equal to G. S one is equal to the given data, sunny, warm, normal, strong, warm, same something like that. And for instance, two, we are taking this another out thing conditions, G to G, S2, like sunny, warm, something like that. For instance, three, so it is a negative output. So this is how it is. For instance, four, it's a positive output. So this all comes from the above table what we saw here. So at last, by synchronizing the G4 and S4, algorithm produced the output. output is something like this is what you will get it for the fourth instance. The candidate elimination algorithm is an important improvement over the finders algorithm for classification tasks. While CEA candidate elimination algorithm shares some similarities with finders, it also has some essential differences that offers advantages and disadvantages. Here are some advantages and disadvantages of CEA in comparison with finders. Advantages of CEA over finders: improved accuracy. CEA considers both positive and negative examples to generate the hypothesis, which can result in higher accuracy when dealing with noisy or incomplete data. And flexibility: CEA can handle more complex classification tasks, such as those with multiple classes or non-linear decision boundaries. More efficient: CEA reduces the number of hypotheses by generating a set of general hypotheses and then eliminating them one by one. This can result in faster processing and improved efficiency, better handling of continuous attributes. CEA can handle continuous attributes by creating boundaries for each attribute, which makes it more suitable for a wider range of datasets. Disadvantages of CEA in comparison with finders: more complex. CEA is a more complex algorithm than finders, which may make it more difficult for beginners or those without a strong background in machine learning to use and understand. Higher memory requirements: CEA requires more memory to store the set of hypotheses and boundaries, which may make it less suitable for memory constrained environment. Slower processing for large datasets: CEA may become slower for larger datasets due to the increased number of hypotheses generated. Higher potential for overfitting: the increased complexity of CEA may make it more prone to overfitting on the training data, especially if the dataset is small or has a high degree of noises. Thank you. That's it.